Hey guys, hope everybody's doing well. Okay, so here we go with the first lesson on in Google Classroom. I'm gonna work through these problems for you. Okay, and let's see. Hopefully, if this works well, this is what I'll continue doing for you guys. Okay, so let's take a look at the do now. It says if the tangent of an angle is negative and its secant is positive, in which quadrant does the angle terminate? Now we know that if tangent is negative, we know that it's not going to be in the third quadrant. And if secant is positive, remember secant is the reciprocal of cosine. So cosine is positive in the fourth quadrant, therefore the angle terminates in the fourth quadrant. Okay, let me see if I can get my writing utensils here. All right, so that's answer number 4. So the do now, answer to the do now is number 4. Let's take a look now. Okay, so today what we're going to be learning about is how to convert from radians to degrees and then back from degrees to radians. It's a lot simpler than it looks. If you took a look through the slides already, you might be a little, confused, but once I get through, hopefully you guys are, will understand it. It's way easier than it really looks, okay? So taking a look at the unit circle here. What is the length of the radius? Okay, so remember, since we're talking about unit circle, all right, the radius, this would be one of the radii, okay? And what's the length of that? We know that it's 1, okay, because that's the value of x. And if I go back in this direction, okay, that's going to be -1, but let's look at this as the absolute value. The length of that radius is the same as the radius going towards the positive values of x, okay? It's going to be 1. So what's the length of the diameter in this case? The length of the diameter would be 2, okay? So if the diameter is 2, let's talk about what the circumference of this unit circle is going to be. We have the formula, circumference is equal to pi times diameter, and we just found that the diameter is equal to 2. So therefore, the circumference of the unit circle is going to be 2 pi, okay? How many degrees are in a circle? 360 degrees, right? So if there's 360 degrees in a unit circle, that means that 360 degrees is equal to 2 pi. And there you have degrees, and 2 pi is what we call the radians. So you see how those two are connected, okay? We have degrees and we have radians. So 360 degrees is equal to 2 pi radians. Now, given this piece of information, we can then calculate, we can change anything that we want. Any type of degree measure we can change into radians. Okay, so let's take a look here. Right in terms of pi, what 180, 90, and 45 degrees would be. The little degree symbol should be up there. They somehow got lost in translation when I turned this into a PDF. Okay, so now let's take 180 degrees. Okay, now if I want to turn that into radians, how much do you think that would be right now? If 360 is equal to 2 pi, how do I get from 360 to 180? Divide by 2, right? So I can take the 2 pi and divide that by 2, and therefore 180 degrees is going to equal 1 pi, okay? For 90 degrees, how much do you think that's going to be equal to? Well, taking a look, if 180 is equal to pi and 90 is half of that, divide each of those by 2, okay? So 180 divided by 2, pi divided by 2, 90 is equal to pi over 2. Okay, and you can leave it at that, pi over 2, or sometimes you'll see it written as 1/2 pi. Okay, they both mean the same thing. Now 45 degrees. Again, take 90, we're going to divide that by 2 again. That gives us 45 degrees, and we're going to do the same thing with pi over 2. If I divide pi over 2 by 2, okay, remember now, this is pi over 2 divided by 2. We're going to change that division to multiplication, turn that 2 into 1/2, and that's going to give us pi over 4. Okay, so we could leave it as pi over 4, or you may see it written as 1/4 pi. Same thing, okay? Not so bad, right? All right, let's take a look at the next page. So here we have the definition of a radian, the measure of a central angle that intercepts an arc whose length is equal to the length of the radius of the circle. So you might remember this. I'm not sure if you did this last year in geometry, talking about arcs and central angles. You may have, I believe. I think this is a topic covered in geometry, okay? So you have that central angle there. If that central angle is, let's say the central angle measures 60 degrees, okay? What is that arc going to be equivalent to, okay? All right, let's take a look on how to convert degrees to radians. Very simple. Okay, when we want to go from degrees to radians, all we're going to do is take the degrees and we're going to multiply it by pi over 180. So if you look back, take a quick peek back at the previous the slide from the two, not the last one, the one before that, where we found that 180 was equivalent to 1 pi, okay, pi radians. Take 180 degrees and multiply it by pi over 180. What happens here? The 180s cancel out and we're left with just pi, okay? If I wanted to convert 90 degrees, all I have to do is multiply that again by the same ratio, pi over 180. Okay, I'm going to simplify. I always like to simplify first, but if you want to multiply through, you can do that. 90 goes into 90 once, 90 goes into 180 twice, and we get pi over 2. Okay, now if we wanted to convert radians to degrees, let's say I had pi over 4, and I want to convert that into degrees. I'm going to multiply now by the reciprocal, okay, 180 over pi. And I'm going to do simplification before I move on. Those pi's simplify, they simplify out, okay? 4 goes into 4 once, 4 goes into 18. 4 into 18 is 4, and we have a remainder of 2, so that's 45. So therefore, pi over 4 is equal to 45 degrees, okay? All right, let's take a look at these sample problems. Now, in question number 4, we have 2 pi. We want to convert the radians into degrees. So for that, we're going to use 180 over pi. So when we're going from radians to degrees, we're going to go 180 over pi. All right, you have to have that memorized. That's not going to be given to you on the assessment exam. An easy way to remember it is, notice that when we convert radians to degrees, there's no more pi left, okay? Pi is not going to be there, which means whatever you're multiplying, the reciprocal, the ratio that you're multiplying by, okay, has to allow for the pi's to cancel out, okay? So 2 pi, I'm going to make that a fraction, so I'm going to put it over 1, and I'm going to multiply it by 180 over pi. Pi simplify out, and that gives me 360 degrees. Just make sure you're putting that degree mark on the degrees so that you're making it clear that that's degrees. For number 5, again, 180 over pi. 2 goes into 2 once, 2 goes into 180 times. 3 times 90 is going to give me 270, and I know those pi's simplify out. Okay, so we get 270 degrees. Number 6. No, wait, let me erase that. I mean to put a multiplication sign there. Okay, so I'm again multiplying by 180 over pi. All right, pi is simplify out. 3 goes into 3 once, 3 goes into 180 60 times. 7 times 60 is 420 degrees. Okay, next one, negative 5 pi divided by 6. Again, multiplying by 180 over pi. Pi's cancel out. 6 goes into 6 once. 6 goes into 180 30 times. Negative 5, don't forget that negative there. Negative 5 times 30 is negative 150 degrees. Okay. Now let's go the other way, degrees into radians. So now if I'm going into radians, I know that my answer, my final answer is going to have pi in it, okay? Which means then that I'm going to multiply this by pi over 180. Okay, pi over 180. It's the reciprocal of what I used in the previous slide, okay? So simplify, I always like to simplify if I can beforehand. 45 goes into 45 once, 45 into 180 4 times, and that gives me pi over 4. Okay, number 9, again multiplying by pi over 180. All right, I can simplify, I can take 10 out of that. So I get negative 5 pi over 18. Multiply 135 over, 135 over 1 times pi over 180. Okay, and I can simplify that. Let's see, well, they're both divisible by 5, I know that. So 135 divided by 5 is going to give you 27. 180 divided by 5, 36. I see I can simplify that further with the 3. 27 into, they're both divisible by 3. So 27 divided by 3, I'm sorry, 9. They're both divisible by 9. 27 divided by 9 is 3, and 36 divided by 9 gives me 4. So my final answer here is 3 pi over 4. You want to get it into simplest form, okay? And last one, again, multiply by pi over 180. Okay, and we can simplify that. Both of them are divisible by, what are we dividing by here? 33, what did I do? Oh, 10 here. Okay, and then they're divisible by 3. So this gives us 11, and this gives us 6. Okay, and our final answer is 11 pi over 6. Okay. All right. Not too bad, right? Okay, number 12. Let's take a look at question number 12. So we got an angle of 3/4 pi radians lies in which quadrant? Now, easiest way to do this is convert it into degrees, and then we can figure out where it lies. So I'm going to rewrite this as 3 pi over 4. I'm going to multiply by 180 over pi, again, because I want to get rid of that pi there. Okay, my degrees should not have pi in it. I'm going to simplify out the pi's. 4 goes into 4 once. 4 goes into 180 45 times. Multiply 3 and 45, and that gives me 135 degrees. So where would that lie? That should be in quadrant 2. Okay, you're doing the same thing for the next one. 5 pi over 4 times 180 over pi. Simplify out the pi's. 4 goes into 4 once. 4 goes into 180 45 times. 5 times 45 is 225 degrees, and that would be in quadrant 3. Okay. Use special right triangles to find the coordinates of the point of intersection of the radian 2 pi over 3 and the unit circle. Okay, so the first thing we're going to do, convert the following to degrees. 2 pi over 3 times 180 over pi. And we get 120 degrees. Okay, now we're going to plot that on the graph. Remember, this is starting from 0. We have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back around 360 degrees. So starting from this direction, I'm going to go around until I hit 120 degrees. Okay, which would be about, I would say about here. Okay, so this would be 120 degrees. And if this is 120 degrees, okay, we need to find the reference angle, which is number 3. Okay, what would the reference angle be? Well, since it's in the second quadrant, we're going to subtract it from 180. So 180 minus 120 is going to give us 60 degrees. So your reference angle is 60 degrees. Notice that's going to be right here, okay? And that's where we're going to base our right triangle off of, okay? So now, remember what the properties of the unit circle are. Our side here, that's our cosine, and that's the x value. And over here we have our y value, which is sine. Okay, so find the cosine of 60 degrees. The cosine of 60 degrees is going to be equal to 1/2. Okay, remember from the chart that you guys had to study, that you should have studied, hopefully you did. Cosine of 60 degrees is 1/2, which means that the sine of 60 degrees is equal to radical 3 over 2. Okay, radical 3 over 2. Now, remember, since we are in the second quadrant, okay, sine is positive. That looks the same. Let me fix this again so it looks radical 3 over 2. Okay, cosine in the second quadrant is negative, so we want to put a negative there. Okay, and the point of this is what we wanted to do was find and determine the coordinates of where that 120 degree angle, okay, or 2 pi over 3 radians intersects the unit circle, which is here. And that point of intersection is negative 1/2 radical 3 over 2. All right, and that's your answer. Okay, guys, for the next part of this, what I want you to do is this slide for your assignment. So what we're going to be doing is you're going to have one assignment basically per week that you need to turn in. All right, you're going to send it to me when you're done. I'm going to check over it and I'll send you back some feedback as to, which ones are correct. If something is wrong, how you can fix it. Okay. I hope you found this helpful. Please let me know if you need any help. I'm trying to set up the Google Hangouts. I was having some issues with it. Hopefully they're all worked out. But if not, feel free to send me a remind message, send me an email. My office hours are going to be from, what did I say, 9 to 10:30, right? 9 to 10:30, and then again from 12:30 to 2 o'clock. So in between those windows, you can try Google Hangouts, and then we can video chat, and I can show you if I need to on piece of paper how to work some stuff out. Okay, so like I said, Hangouts, remind, email me, however you want to is fine, and I will be here to help you guys out. Okay, have a great afternoon. Hope you found this helpful, and I hope to see you guys soon. Bye.